in version 14, we have a number of new upgrades and features that we're going to talk about. The most important are support for all major releases of different database servers. So for example, version 14 will support SQL Server 2014, Postgres version 9.4, which is still in beta, but we are working with it to make sure that it's supported. MySQL version 5.7, and Oracle 12c is already supported through our version 12. Another major feature is the integration with various new features introduced in DataFlex 2014, like DDO SQL Filters, new table editor, and Oliver will go into that a little bit. At the driver level, we are introducing a modified and enhanced LOB support with the major speed improvement. Though we have had some LOB support over the years, it didn't really integrate well with DataFlex code, and today Oliver will show you how these LOBs can now be integrated into the DataFlex code to do some really cool stuff. The product is currently in release candidate mode and is available for download. So if you're interested in downloading and testing it after the webinar, you're welcome to do so. So Oliver, I'll hand over to you to continue.
Okay. Yeah, so as Riaz was mentioning, really there's three major areas that version 14 focuses on with the new server version updates, the DataFlex 18.0 compatibility, and then the improved LOB access. So the first area we're going to really talk about here is in relation to DataFlex 18.0 support. And really, data access added two main features into 18 that were related to the drivers. One of those is the native data type editing. The other is the DDO SQL Filters feature. Now, the native data type editing, essentially, if I just go into it here, gives us a way simply of editing a table where we can basically come in here. Let me just add a field. We're going to do whatever, where we can select the data type from the server that will map to a DataFlex type. Essentially, gives you a way of doing this inside of the studio. Now, in the case of Mertech's driver, we actually have some real issues related to this because, of course, we've got support for PostgreSQL, Oracle, MySQL. There's a lot of types that have to be mapped to DataFlex types. And Data Access actually did a really nice job with this. The way they enabled that support really focused on allowing us to enable it as well. And they did it by way of these XML files. This is a sample of one of them that we've created for our Oracle driver that essentially deals with what the driver supports and what the native types are in that driver. So, for instance, if we go down here, we can look at that in Oracle there's this interval type, and essentially it gives it a way of mapping that type back to what a DataFlex type will be for that. So they actually made this this really malleable system for us to use, so that we could actually allow this type of editing right inside of the IDE, and it works really well. I can go in here and add a time zone based timestamp in here, and or maybe not right now. Everything wants to be a big int on me. Let's see here. Of course, while I'm demoing it, it decides to cause me grief. Tested this earlier this morning and it worked perfectly. Anyways, maybe I've got a bad version of this right now. Essentially, this XML file allows us to map these things forwards and backwards so that we can support these types. Essentially, this is very similar to what our Flex2SQL utility has to deal with as well. If I go in here and connect to it, and and we're going to go to restructure table. We have something very similar in here, where you can select what the DataFlex type is and then pick the backend type that matches that. So essentially, it's giving the DataFlex IDE a way of doing the same thing that we're doing there. So that's one of the features. So you can see we're still working out some kinks with that one. The next item that they added was really related to SQL filters. So let's close this out. We are going to switch over. Actually, I think we've got one right in here. So SQL filters basically give you a way of dealing with a back-end database constraint that you can set up in your data dictionaries, but that basically gets that constraint, just like you would use an on constraint in your DD, this sort of constraint gets run on the server. So for instance, if we were to go in and look at the wines entry view, and we go into our DD here, it's done via the two properties. One of them is this PSQL filter call that basically sets the constraint, and then this Boolean use DD SQL filters that turns it on or off. And essentially, this is something we had something similar that the Mertech driver had before that was global. So for a global file buffer, you could set a server-side constraint, and essentially that would be used throughout your application, and it would work in DDs and all over the system. The way Data Access implemented their SQL filters in the data dictionary actually fit very well with what we had done, and so it made it real easy for us to enable the support just the way their driver supports it as well for SQL filters. And of course, in our case, those SQL filters have to support all the various backends. So like in this case, we're connecting to a Postgres backend, which has some interesting stuff related to the way they want the various constants escape. So that's why this is a kind of odd-looking string here. But in this case, what we've done is we've essentially just made a simple filter that filters out all of the wines that have a bin that begins with the term box. Now, this could have been done via an on constraint where we did a true expression evaluation, but essentially what would have happened in that case is all of those records would have had to have been filtered by the DataFlex application to determine whether they met the constraint. By doing the filtering on the back end, all of those record calls to the server, all of those calls to the server never even take place. So like in this case, you can see there's all these boxes as bin numbers in here. And this is just a very simple one, but in this case I can exclude these. And essentially, I went straight from B4 to C1. I skipped all of them that had the term box in them. Now, this is a very simple sort of item here. These can get much more complex, but the fact that you can run expressions that are going to get added into essentially the SQL statement that the driver builds on the back end gives you a lot of power as to what you can do. And I'm actually going to show you another example of this in just a little bit. So essentially in this case though, you can set the expression, and then what I've done is just created a checkbox that toggles whether it's on or off is all in this case. So basically those are the two major new features that were added into 18 that were related to connectivity that we implemented in our 14 driver. Now the next major item that was implemented into the 14 driver actually relates to LOB access. So when we talk about blob, we're talking about these binary large objects. Essentially, it's a way of storing large chunks of data in a database column that may be in a binary format. People sometimes store files in there, although it can be lots of other types of content as well. So in our prior driver, in version 12, for instance, we had support for blobs. But the way the support was implemented was by way of these 16 kilobyte chunks in the field, and you use some custom commands to access them, and it was a little bit odd the way it worked. It didn't make a lot of sense. Programmers sometimes had problems with it. To give you an example of what it looked like before, so that we can kind of have a comparison to what we have now. Let's close this out. And we're going to go look at the old method. So essentially what we would do here, in this case, I've got a picture that I'm storing in a field. I've augmented, now in this case I'm connecting to a SQL 2014 server, and I've augmented the salesperson view and the order entry. You may be familiar with this view. I augmented it so that we can actually show a picture down here. Now the way you would have read a picture out of the database with the version 12 driver was basically by way of this code. And essentially what you do is you get the length of the field using this custom command called LOB length. And you'll notice here that you pass the database, and then you have to pass actually the field number. You have to go look that up. And then essentially you call LOB read, and in this case you have to pass variables in. It was just a little inconsistent that way, and essentially it wasn't clear what exactly was happening. What in fact was happening in this case is that it was loading the next 16 kilobyte chunk of data into the salesperson dot picture field. In this case, it was loading it into the field, and you could then get it out and basically build up whatever was in there. And the one advantage this method had, the one big advantage, was that your record buffer stayed small. So with the data access driver, they actually have straight field level access to blobs. But the problem associated with the blob implementation in the data access driver is that you have to basically set the field to a certain size that is going to fit whatever data you're going to be putting into that blob field in, and that essentially makes your in-memory record buffer that large. In some cases, that's just fine and it's not a problem, but you know, if you could store 100 megabyte file, for instance, in that field, your record buffer is going to be very large in memory all of the time when you need access to that field. Our method didn't have that problem, but it had another problem associated with it, which is that you were limited to getting your data out 16 kilobytes at a time, which just isn't enough anymore. And so we were actually dealing with a few different problems. One was the 16K access. The way that the data access driver did it, we saw a couple of issues there, but we wanted something more consistent with the DataFlex way. And when you're dealing with 16K at a time, if you're going to put something into a blob field that, you know, is many megabytes in size, well, that's a ton of chunks of data to have to send or read out. And also the way the writing worked was not compatible with data dictionaries. There were quite a few different problems. So we essentially took a fresh look at all of this and tried to fix all of these problems. And so let me show you what we came up with for that. So let's show you the end result of it first, so you can kind of see what we were going for here. Now in this case, I'm using a imaging control from AccuSoft called Image Express, and I just have a trial of it installed for this purpose. And essentially, I wanted to be able to show to work with the data dictionary and to show a picture for a salesperson. So this is Barbie in this case. I just went and grabbed some pretty high quality JPEGs off the internet to show you here. So you're going to see some people you may have seen before. Next up, Barney Roberts is Emma Stone. And so, you know, I went through and I grabbed various pictures, and basically we're loading them in here, but all of this is being done through the data dictionary. For this imaging control, in fact, there's no data ever touching a file in this case. So let's go look at how we did this, and then we'll look at a couple of the features related to it. So this is basically broken up into two calls. The one to display an image, and then we'll look at how we're actually saving an image into the database, because we have that support in here as well. So I'm making use of the on-post find procedure. And basically, when we have a new record that's come into the buffer, I tell it that we want to go out and load the image. And if we go look at how our load image works, I actually use this as an example of how to do chunking as well. We could have just gotten the image back all in a single call using the SQL get lob call. But in this case, I wanted to show how chunking support works. And we have chunking both to write into the blob field and to read out of the blob field as well. And so in this case, essentially what I do is I go out and I get the length of the data that's in that field. And notice I'm just using file.field in this case. The interface is simplified quite a bit. And what I do is I go out here and I start reading chunks from the file. And based on whatever is in there, I just loop through and basically build those into a string. Now, to get it into the imaging control, I have to do a little bit of type work here to convert it into the type that's needed for the control. But essentially, this is the key to it, is just looping through and getting chunks out of the file and building those together. I could have just as easily done a call like SQL get lob sales p.picture to s bitmap and gotten the entire string, the entire bitmap back in one call. Now, there are some advantages to this sort of secondary command interface that we built here. One is that it's much simpler to understand what we're doing. And secondly, since we're not directly working with the file buffer, we're not extending the size of that file buffer in memory. We're basically just allocating a string right in here based on the size of whatever is in that field. So essentially, our memory usage only is ever going to increase directly when you're using the bitmap in this case, and there isn't a big overhead to it otherwise. So that's how we read from it. Now, the way we write to one of these, basically the way I set it up for writing in this case, let's go out and just show you the interface so you understand how we're working with this. So I think Bob Stimson doesn't have one here. So we're going to go out and, we'll just use Tuxedo Guy here. Now, I went out and basically I've allowed you to pick a new image for control, and notice my save button became enabled here. So I'm going to go ahead and save it, save this record. And now I have that image for Bob Stimson. So let's look at how we did that. Stop this. So this is really where one of the big improvements in the new LOB support is visible. With the way our LOB support worked before, essentially you would have to go in and use a command called lob append that essentially took 16K and added it onto the field and saved the record at the same time. That was problematic because it basically broke compatibility with data dictionaries. With this new LOB support, essentially you make use of two commands. There's SQL set lob, and if you want to do chunking, there's SQL add lob chunk that basically builds up this image data into an in-memory buffer for our driver. And notice there's no save in here. Well, that's because the data dictionary save is. If we've got a new image that I need to save, I open the file for the image that they pick, find out how big it is, and essentially read that into using our SQL set lob and SQL add lob chunk commands, and that's it. When the record is saved via the data dictionary in this case, that data is written out as is. So it's very compatible with the data dictionary, and this is really where chunking support gets interesting. So in this case, I use chunking support simply to illustrate how it works. So we have an example of that, and that you can look at. I could have just as easily, again, just like reading it out, I could have written it all in one large chunk using SQL set log. And I could have done the entire thing rather than looping through it. The advantage of chunking actually becomes visible when you go to use it in a web application, for instance, where you may actually have a client sending chunks of data to the server, and you get a call for each one of those chunks of data that you essentially need to add on to the blob field. Before this, or with Data Access Driver, essentially you'd have to build that up using some other mechanism locally on the server. Once you had the whole thing, then you could take it and write it into your database field. In this case, with the chunk support, you could simply find the record that you need to work with, tell it to add a chunk onto the end, and then issue a save record afterwards. And that additional chunk would be written into that blob column. And therefore, you have this ability to write all the way back from the client without a whole bunch of extra plumbing, essentially, to deal with building up the whole file. So very data dictionary compatible in this case, and essentially makes it really simple to use. So one of the other things that I wanted to show you in relation to this, if we go back in here, if I go through here, I've got, I don't know, 6 records or so with images, and then after that I have none. Now, if you wanted to, for instance, constrain this view to only show salespeople that contained images, this is where SQL filters actually work really well, because essentially you're going to have to read that blob field to tell if you need to do that constraint using the old DataFlex on constrain methods. But using the SQL filters, what we can do is, let me just turn it on here. Let's clear this. Essentially, I can turn on this filter that limits me to only records that have data on them. So if I press this again, it won't go past that at all. And essentially, I'm limited to only records that contain image data in this case. Now let's look at how I use the SQL filter to do that. So essentially, it's a very simple filter in this case, where I'm going in and basically modifying that call that's being done to the server, and I basically go in and check to see if the picture field is null or not. Because in this case, if there's no image data in it, we make that picture field null. And so by doing this simple check at the server side, I'm limiting what data comes back to the client and really reducing the amount of data that comes back to the client, since I'm only going to be returning those records that don't have that image data without having to actually return image data to see if there's image data. So it gives us a very efficient way of doing what would have otherwise been a very difficult thing in DataFlex. So these SQL filters are really going to be a nice feature for you guys to use. And this is only the beginning of what they're capable of. These expressions can get very, very complex based on what you may want to do with them, handling things like regular expression searches and all kinds of stuff like that, where all of that's going to be done server side. So very powerful feature.
Oliver, I have a couple of questions for you.
Sure.
First question is, does it work with any specific version of Visual DataFlex, or it's supported across other versions of DataFlex as well?
The LOB support.
Yeah.
LOB support will work with other versions of DataFlex. It won't work with console mode versions, but it should work back to very early versions of DataFlex for the new LOB support we added.
So VDF 7 onwards will all
yes.
work. Okay. And the other question is here from Chuck, saying, doesn't the save increase the size of the record buffer when you do the save?
No, this isn't increasing the size of the record buffer in DataFlex. It certainly, that data is being buffered. So for instance, if we go and look at this, the SQL set lob, that data is being buffered by the Mertech driver. And yes, so all of that is being buffered while that save, until that save is complete, that is buffered in memory. But as soon as you're done with it, it's gone. And you'll notice that one of the things that I forgot to do, but essentially that I should have done in here, was to reset the argument size after the save has occurred, back down to what it was before. And essentially that'll get rid of the rest of what's used as soon as this procedure finishes executing. So yes, there is buffering, but it's only going to be for whatever size of data you're going to put into it at that point. Whereas with the way that the data access driver works is you're going to have an allocated record buffer for whatever size you think is the maximum. So some people may have need to set that very high to 10 megabytes or something, and that's going to be there all of the time. And in fact, it's going to be there duplicated for each data dictionary, each view that has this data dictionary in it. There's going to be a buffer of that size allocated, so it can grow very quickly. This method, again, the increased memory is only going to be in use when you're using the blob. Does that answer the question?
Chuck, that answers your question?
Yes. Oh, I didn't know I was on.
I unmuted you, so you can go.
Oh, okay. No. Oh, that's what I was wondering about. It's just that it's going to be there at some point, and I was just interested with the save file using the DataFlex save logic, whether it wasn't going to be increasing the file buffer size at that point. I guess it just goes away after that.
Correct, and it's never technically increasing the file buffer. It's a separate buffer that we've set up for this use.
Okay.
So, which means it's not going to get duplicated anywhere or something like that. Where your application is going to grow in memory exponentially. So
if you do not reset the argument size, then the buffer remains in place. So there is an overhead in creating and destroying memory also at the lowest level. So if you think that your file sizes are not that big, you could probably leave it there if memory is not a concern to you.
One of the other things that you could do if memory really is a concern is to make use of the chunking support. So in other words, instead of building up, like in this case for the for reading the blob, essentially I'm building up a string that contains the entire bitmap, and then I do a conversion on it down here. But a lot of tools give you other means that you can access it, and the chunking support really can reduce your memory usage because, well, like in this case, I've set my chunk size to 2 megabytes. But let's say you set your chunk size to, 256K, something like that. Yes, it's going to require many more calls to get those chunks, but you've reduced your overall memory usage if you can avoid building up the whole string as well. And your argument size doesn't need to be set to the full image length. You could set your argument size to your chunk size, for instance. So there are some techniques using chunking that you can work with to reduce the memory footprint if that's a concern, such as on a terminal server, for instance. So that's our LOB access. Now, one of the big benefits of this, and really it's not one that I have a great way of showing you, unfortunately, is the speed related to it. So the old method that we had, just to give you an idea of kind of how fast this is, one of the reasons I wrote this right here, this call, was essentially to, and that one's not going to work anymore because there isn't one on there. So let's see. Let's go, I think it's CW. So let's go in and tweak that real quick so we can show that to you. Change that to CW. Okay, so this was using our old interface, which is still there. So, you know, if you have code using that, you know, it's still accessible. So, and this is the timing that it took, not to load the image on the screen, but the timing just to read this image out of the database. And the reason I chose this image specifically, this is a 6 megabyte JPEG. It's a pretty big file that way for just an image. And you can see here, it took just shy, it took about 1.8 seconds to read this image in using the old method. Now, if we were to go in and just take a look at our new method, and basically I do a show line of current date time around the code that actually reads it from the database. And I pull up CW. So you'll notice the amount of time it took to actually read it from the database here is less than 1/10 of a second versus almost 2 seconds. And in fact, it took a lot longer for the imaging control to display the image, just to process the JPEG and display it, because it's such a high, such a large JPEG. This is significantly faster. In most cases, you're going to see a minimum speed increase with this new LOB interface of 20x. It's just really, really fast in comparison. And part of that, of course, is because you're not having to read 16 kilobyte chunks anymore. You know, we can read the entire image in. In this case, I have it set to read this thing in 2 megabyte chunks. And, you know, if you were to read the whole thing in with no chunking support at all, just in one call, it'd be even a little bit faster that way without having a big overhead memory-wise. So much faster support overall. Same thing on writing, because you can write in much larger chunks, of course, as well. So we've tested it up to you know, fairly large chunk sizes. Most database systems, of course, don't want you to write huge amounts of binary data into blob fields. You know, they're telling you, well, there's these limits have changed over time. Some of them have said, well, no more than 16 megabytes, otherwise might as well store it in a file. Some have said 64. But there are lots of companies out there that are using blobs that are writing in, you know, multiple hundreds of megabytes into the database that way. And, you know, the newer database servers are getting more efficient at dealing with that internally, where they know basically how to take that data, and maybe they're not storing it in the database directly, but storing it externally themselves. And, you know, they're starting to deal with that situation for you, so that as a developer, you don't have to worry about that as much, and basically can put whatever you want in there. So,
Oliver, Chuck has a couple of questions again.
Sure.
One is have you tried this in web app?
Yes. Yes. You know, we've worked with chunking support in web app. It's actually specifically in a web application where we first really saw the need to improve this. So yeah, it's been tested there.
Okay, and the second part is, how does this work with the sync DDO stuff going on there?
With the sync DDO stuff.
Chuck, maybe you might want to elaborate that a little bit.
Well, Oliver, you know how the data access basically stores a shadow copy of the entire DDO structure and puts data in that shadow copy. So, I mean, is this going to be excluded from that data that's stored locally on the client?
Yes.
With the LOBs?
Correct. This is not going to be. I understand what you're saying now. Yeah, this is not going to be stored in there. The data from these LOB fields is only accessible via these commands. You can read from the field directly. That isn't an interface we really have tested much or have worked with much. Certainly that is there though. But if you were to go in and look at the definition for salespeople, you'll notice, I mean, it thinks that this is a 16 kilobyte field. Now, of course, on the server side, you can see it's var binary max, so it's not at all. But so you know, there is still some access to some of the data in here via the field directly. But in general, no, that's going to be excluded from that shadow copy, essentially. So if you want to have access to this data, essentially you have to provide a custom interface for it.
I'm just curious whether that would be allocated on the. I'm not sure how they store the data in that TWeb, the data dictionary on the client itself. You may know more about that, but I don't know if they're going to have to allocate. They'll still allocate the 16K.
Well, the 16, yes, there's still going to be an allocated 16K, but that's those fields in general they have turned off to read from by default.
Okay.
So I don't think that's going to come over at all.
Good. Thanks.
No problem. So the next area that I just want to kind of briefly mention here is really in relation to the latest server versions. So you know, as Rios mentioned, this is where we worked on support for these. So what did we have to do for support for these database backends? Well, if you go and look at essentially what was added in SQL Server 2014, MySQL 5.7, PostgreSQL 9.4, this release really was focused on, from all three of them, was focused on backend support. So for instance, Microsoft added support for a durable in-memory database, so that you could have certain tables that are still durable, have full transactionalism, but are stored completely in memory all of the time and written out to disk for durability reasons. Well, that's not something we had to really do anything for. That backend support being added there was, was basically all that needed to happen for you to access it from Mertech's driver. And lots of those kinds of changes, we did have to make modifications for all of these a little bit, but a lot of that was very minor. It was mostly testing with these new, these new versions of it. And in fact, we're having to test with the betas of them now. So, there may be some possible changes there since none of them are quite at a release candidate stage yet that we've been able to test against. But essentially, all of the focus for these releases is those backend items. PostgreSQL improved their table editing support, and actually MySQL did the most work on that, where basically they have much broader support for alter table now, which MySQL was always very limited on. So anyways, you can download a trial of the beta of the version 14, or excuse me, the release candidate of version 14 drivers from us and connect to all of these. And we're actually doing some testing right now with the version 12 driver to make sure that, especially like for MSSQL, that you can connect to a 2014 server without problems as well. Just you wouldn't have access to anything new that 2014 has that way. But that's one of the areas we're checking on as well, so that you don't necessarily even need to upgrade your driver if you've already released with a version 12 series.
Yeah, you'll just need a new registration code. If you have maintenance, you'll just get the registration code, and then you'll be able to use the existing version 12 drivers with SQL Server 2014. And our initial testing, it doesn't look like it's going to be a big issue. We just want to make sure we go through all our testing suites before we officially say it's supported. But people have been using it, and we haven't heard any problems about any problems so far.
Correct. So, and that is version 14 release candidate. As for an actual release date for 14, that's kind of a little bit of a moving target. We want to allow you guys to try it out some more, and but it is coming very soon from that perspective. So, and certainly you'll see the announcements in that way. And you know, want to open it up to any questions. If anyone else has any questions, feel free to ask.
Just a comment, Oliver, on the release of this version. We are shooting for probably within the next 2 weeks.
Yes.
Right. So it's not really dependent on you know, some of the testing results we might get back. Yes, we skipped 13, Chuck, for obvious reasons. We just didn't want to risk it. All right. Any questions? You can always send us an email. We are available by phone or email. If there's I don't see any other. Okay. All right, so we're going to end this session. Thanks for attending, and hope to see you again soon with another webinar. Thank you.
Thanks, guys.